Hi dear students, welcome you all to another session of Brainiacs Doubt Clearance. Okay, so we have a new question in front of you. I will just read the question. The number of atoms of chromium and oxygen are 4.8 into 10 power 10 and 9.6 into 10 power 10 respectively. Its empirical formula is. Okay, so before we start with this question, I will give you some idea on how to find out this question. So it will be easy for you. Okay, so to understand that, let me take a compound. For example, let me take Al2O3. Okay, this is just an intro for your understanding. Al2O3. I am taking aluminum oxide. So how will you interpret this formula? I know that Al2O3 means it is made up of, if I am talking about one molecule, okay, please listen, the terms are very important. I am speaking about one molecule. Then it means what actually? I can say two atoms, two atoms of aluminium, correct? Aluminium combines with, combines with, combines with three atoms of oxygen, correct? Oxygen to form one molecule of L2O3. Suppose if I am writing this as 1 mole L2O3. Okay, then how we will interpret it? Can I write two atoms of aluminum? Instead we say 2 mole of aluminum atoms, correct? 2 mole of aluminum atoms combines with, combines with 3 mole, 3 moles of oxygen atoms, correct? Okay, now even this can be interpreted in another way also. What is the other way we can write this? 2 mole of aluminum atom means what actually? 1 mole is equal to Avogadro number. So I can write 2 into 6.022 into 10 power 23 aluminum atoms, correct? Combines with, combines with 3 into 6.022 into 10 power 23 oxygen atoms, correct? Okay, so why I have explained all these things, this is to for your understanding actually. So that means the formula of Al2O3, how I can arrive at, now I know that aluminum atoms, aluminum atoms, how many aluminum atoms are there? You got it as 2 into 6.022 into 10 power 23, correct? And oxygen atoms is how much? Oxygen atoms is equal to, you know that it is 3 into 6.022 into 10 power 23. And if I take the ratio of both aluminum to oxygen, if I take the ratio, you know that it will become 2 into 6.022 into 10 power 23 divided by 3 into 6.022 into 10 power 23. So this will get cancels off and you will get 2 is to 3. So this is how I am getting as Al2O3, correct? Now, similarly, the same approach can be used here. Okay, so if you see here, how many chromium atoms are given? You can see here chromium atoms given here are, okay, I will choose another color for explaining this. Okay, so let me choose pink, violet. Okay, so let me see how many chromium atoms are given to you. So in the question they have given the number of chromium atoms, number of chromium atoms is equal to how much? It is given as 4.8, 4.8 into 10 power 10, correct? Now similarly, number of oxygen atoms, oxygen atoms is equal to how much? It is given as 9.6 into 10 power 10. And if we are able to find the ratio of this, so ratio of this means the simplest value you will be getting. So 4.8 into 10 power 10 divided by 9.6 into 10 power 10, you will get the empirical formula. So this will get cancels off and this will become 1 by 2. So that means what? CrO2 is my simplest formula out of this. So CrO2 is my empirical formula. So is that present in the option? Yes, you could see it is present, CrO2. So my answer is option B. So I hope you understood the explanation. If you have any doubt, please feel free to come back. So we have a good question in front of you. I will just read the question. Okay. Caffeine has a molecular weight of 194. If it contains 28.9% by mass of nitrogen, then the number of nitrogen in one molecule of caffeine is. So this is the question actually. So how we can solve this question? So we will first of all read some statements of this one. So they are telling caffeine has a molecular weight. So we will say the molecular weight of caffeine, correct? Caffeine is equal to 194. What does that mean? If you take one molecule of caffeine, it has a weight of 194. That is the meaning actually. Okay. Now, next thing what they are telling, if it contains 28.9% by mass of nitrogen. So what does that mean? That means that 28.9 gram of nitrogen is present in, correct, is present in 100 gram of caffeine, correct, 100 gram of caffeine. Now we know that it is percentage. That's why I am saying 100 gram of caffeine. And many of them will ask you, sir, why you have taken gram? It is not necessary that whenever they say by mass, always we can take gram. Since it is a ratio, we can do it in any way because while dividing, this will get cancels off. So even we can say like this, that will be more better. I can say it like 28.9 AMU of nitrogen is present in 100 AMU of caffeine. Okay. So why I will prefer the second one compared to the first one. The reason for that is we are talking about one molecule, correct? One molecule of caffeine. So whenever we speak about one molecule, we always used to represent with AMU. Whenever we speak about one mole, we used to represent using molecular mass in grams. So we will prefer AMU here. Okay. So that means 28.9 AMU of nitrogen is present in 100 AMU of caffeine. Correct. So I will write it in much clear form. 28.9 AMU nitrogen is present in 100 AMU caffeine. Okay. But what we are expected to know, we need to know in 194 AMU of caffeine, how many AMU of nitrogen is present. Why we need to find out in 194? Because 194 they have given it is the molecular weight of caffeine. So, and they are asking you the number of nitrogen atoms in one molecule of caffeine. So we know that one molecule of caffeine has a mass of how much molecular weight, which is equal to 194. So we will try to find out the number of nitrogen or the mass of nitrogen in uh, one molecule of caffeine. One molecule of caffeine means it has a mass of how much? 194. So we need to convert 100 to 194. So how we can do that? First we will convert this to 1. For that we will divide by 100. So when we are dividing by 100, this will become 1 AMU of caffeine, correct? So here also you need to divide by 100. So this will become 28.9 by 100 AMU nitrogen. correct? Okay. Now tell me how to convert 1 to 194 multiply by 194. Okay. So this will become 194 AMU of caffeine, correct? So and do it the same thing on the LHS. So this will become 28.9 divide by 100 into 194 AMU of nitrogen. Okay. Now we know 194 AMU of caffeine, that is the molecular weight of the caffeine, has how many mass of nitrogen. So when you do this calculation, you will get an answer that is equal to 56. So you can do that. So this value will become 56 AMU. So that means what actually? So if you take, that means one molecule, I will write the inference so you will get an idea. So I can say that if I take one molecule of caffeine, one molecule of caffeine, correct, which has a molecular weight of 194, one molecule of caffeine nitrogen has nitrogen of mass 56 AMU. But are they asking you regarding how much mass of nitrogen is present in one molecule of caffeine? No, they are asking you regarding the number of atoms of nitrogen. Correct. So I know that one nitrogen atom, one nitrogen atom has a mass equal to 14 AMU. Now, can you tell me how many atoms are present in 56 AMU? I know that I should multiply by 4. So this will become 56 AMU. So you can multiply here also by 4. So this will become 4 nitrogen atoms. So what is that understanding? Now we understood that 56 AMU mass of nitrogen means it is equivalent to 4 nitrogen atoms. And 56 AMU of nitrogen is present in how much mass of caffeine? 194 AMU of caffeine. This 194 AMU of caffeine is the molecular mass of the caffeine. This is what indirectly they are asking you. Okay, so I got the answer as 4. So it is present as option C. So I hope you have understood the question. If you have any doubt, please get back to us. So today I have come up with one of the good questions. So you can just read the question. Okay. An oxide of a metal M contains 40 percentage by mass of oxygen. Metal M has an atomic mass of 24. Then find out the empirical formula of its oxide. So this is the question. So how to do this actually? So first we will try to see there is something called a metal was there. Okay. And it combines with oxygen to form some metal oxide. We don't know what it is. Okay, I don't know the formula. I will just write here metal oxide. Okay, so this is what I know. Now they are telling an oxide of a metal contains 40 percentage by mass of oxygen. So that means what actually? If I take 100 gram of the metal oxide, 100 gram of the metal oxide, 100 gram of the metal oxide contains tell me contains 40 gram of oxygen, correct? That is the meaning of the first statement. So tell me, if 40 gram of oxygen is present in 100 gram of the metal oxide, what will be the mass of the metal? I can say that mass of the metal mass of the metal in 100 gram of metal oxide, 100 gram of metal oxide is how much? 100 minus 40, which is equal to 60 gram, correct? So I got it as 60 gram. Now what they have given to you? They have given to you the atomic mass, correct? So we know the given mass and atomic mass. What can be calculated? The number of moles. So I can say the number of moles of the metal. Number of moles of the metal is equal to how much? Given mass. Given mass is 60 divided by atomic mass. So the atomic mass given here is 24. So what will be the value? 60 divided by 24. So this will become 2.5 mole. Correct? Now similarly find out the number of moles of oxygen. So the number of moles of oxygen is equal to, tell me what is the given mass of oxygen? We know it is 40 divided by how much it will come? The atomic mass of oxygen, it is coming around 16, and that value will be again 2.5 mole. So what does that mean actually? You have 2.5 moles of metal and 2.5 moles of oxygen is there. So that means what will be its simplest formula? Both will get cancelled. So for I can write it like M metal to oxygen ratio, that is 2.5 divided by 2.5, that will become 1. So that means my simplest formula is MO. So some students will still have doubt. Then what I will say is another way of interpretation is metal 2.5. Metal is 2.5 mole, right? Convert this into number of atoms. So what it will be? 2.5 into Avogadro number, correct? And oxygen again it is 2.5 mole, correct? So convert this into number of atoms. So this will become 2.5 Na. Now compare the metal to oxygen number of atoms ratio. Again you will get the same value, 2.5 Na divided by 2.5 Na. Both are correct, right? So again this will become 1. So I can say metal to oxygen ratio is 1:1, or what I could infer, I can say that my empirical simplest formula is MO, correct? MO. So we will check whether that is given in the question or not. Yeah, the option A corresponds to that. So my answer is option A. So I hope you understood the question. If you have any doubt, get back to us. This question is very important actually, because this already it came for Neet, and we are also expecting this type of questions for Neet actually. So this will check whether you have a clear understanding of mass percentage, that is mass by mass ratio. Okay, and you have any idea regarding the molecular formula. This is what this test actually. Okay, so let us start. So they are talking about, so I hope you could see the question. Just read the question. Two oxides of a metal contain 50% and 40% of the metal respectively. If the formula of the first oxide is MO2, then the formula of the second oxide is. So here we are talking about two oxides. So let me say this is my first oxide. Okay. So my first oxide is, they have told it is MO2. Now in the first oxide, they told what is the percentage of metal in the first oxide. So the percentage of metal in my first oxide, they have given it as 50%. Correct? Okay. So 50% they have given. And so what will be the percentage of oxygen then? So the percentage of oxygen in this case is 50%. How we are getting it? Because total is 100. So 100 minus 50. Correct. So you will get it as 50%. Now, in the case of second oxide, what they are telling, okay, we will talk about second oxide next. So from this, what is the meaning actually? Percentage of metal is 50% means what actually? So we know mass percentage formula, right? So I can write mass percentage of metal is equal to 50%. That means what? 50 gram of metal is present in 100 gram of the metal oxide. Correct. So that is the meaning of that. So I can say mass percentage of the metal is equal to 50%. Correct. So let me write So I can say mass percentage of the metal can be written as mass of the metal, mass of the metal divided by total mass, divided by total mass of the metal oxide, total mass of the metal oxide, total mass of metal oxide, correct? Metal oxide. Okay, total mass of the metal oxide into 100 will give me the mass percentage value 50. Correct. So we don't know the mass of the metal. So let us assume the mass of the metal as X. We say the atomic mass of the metal as X. So let's assume atomic mass, atomic mass of metal equal to X. Okay. So we know that atomic mass X divided by total mass. So we know that the formula of the first one is MO2. So that is X plus O2 means 16 into 2, 32 will come into picture, correct? Into 100 is equal to 50, correct? So how we can calculate X from this? We can rewrite the equation as X divided by X plus 32 is equal to 50 divided by 100. So this will become X by X plus 32 is equal to 1 by 2. Correct? So we can cross multiply this. So this will become 2x is equal to x plus 32. So if you are bringing x here, x becomes 32. That is atomic mass of the metal, atomic mass of the metal is equal to 32. I have got. Now we will talk about the second oxide. So in the case of second oxide, they are telling 40% of the metal is there, correct? So I may say for second oxide, we don't know the formula. So we write second oxide, the percentage of metal, the percentage of the metal is equal to how much? 40 percentage, 40. So what will be the percentage of oxygen here? So we know that if 40 percentage is metal, that will be 100 minus 40 and that will be equal to 60. So what is the meaning of that actually? Percentage of metal is 40 means how I can write 40 gram of metal is present in 100 gram metal oxide, correct? 100 gram metal oxide. Now let me calculate the number of moles of the metal. So number of moles of metal is equal to what actually? Given mass, that is 40 gram divided by atomic mass. So atomic mass we have calculated it as 32. Okay, because the metal remains the same. So in our first calculation we have calculated it as 32. So what is this value? We can cut with 8. 8 into 5 is 40. 8 into 4 is 32. Correct. So it is 5 by 4. And number of moles of oxygen is equal to how much? Tell me. So it is 60 gram, correct? 60 percentage of oxygen means 60 gram of oxygen is present in 100 gram of metal oxide. So I will put 60 divided by the atomic mass of oxygen, that is 16, correct? So if you divide it, you can divide by 2, this will become 8 and this will become 30, and if you still cut it, this will become 15 and this will become 4, correct? So I can say 60 by 16 or 15 by 4. 15 by 4 is approximately coming around 3.75. Correct. Because 4 into 4 is 16. So it will be 3.75. And 5 by 4 is approximately around 1.25. Now tell me metal to oxygen ratio here is 3.7, 1.25 1.25 to 3.75. But they are asking you what actually empirical formula. So to get the empirical formula, you should get the lowest possible ratio. So how can you do that? Metal to oxygen ratio is equal to 1.25, okay, 1.25 to 3.75. So to get the lowest value, divide by the smallest number. So that is 1.25. So let me divide by 1.25. So this will become 3.75 divided by 1.25. So this will get cancelled as 1 and this will get cancelled as 3. So tell me, metal to oxygen ratio is 1 is to 3. So my expected empirical formula is MO3. So let's see whether that option is present here. So I could see here an option MO3 is present in the option C. So option C is my correct answer. So I hope you understood the concept here. If you have any doubt, get back to us. There is a good question in front of you. Just to read the question. The density of a liquid is 1.2 gram per ml. There are 35 drops in 2 ml. The number of molecules in one drop is. This is the question. Okay. So I hope you understood the question. So we'll try to see it line by line. So density of the liquid is given. Okay. So that means there is a liquid is there. So I can say the density of the liquid. Okay. So density of the liquid is equal to, okay, density of the liquid is equal to 1.2 gram per ml. Correct. So density of the liquid they have given. Hmm. Now what they have given, there are 35 drops in 2 ml. So they are telling there are 35 drops in 2 ml. So we will say volume of the liquid. Okay. So we will say volume of the liquid is equal to how much? They are given 2 ml. Correct. So volume of the liquid is given as 2 ml and we know the density of this liquid is this much. Now what we can find out, we have our standard formula, density is equal to mass by volume. Correct. Density is equal to mass divided by volume. Now what we can do here, listen, now we know that, so we want to find out mass actually. So I can say mass of, how much drop it is actually, you can see here 35 drops. Correct. So mass of 35 drops, 35 drops of liquid, 35 drops of liquid is equal to what, it will come, volume into density. Correct. Volume into density. Now what is the volume given? We know that volume is 2 ml. For 35 drops it is occupying a mass of, it is occupying a volume of 2 ml and density of the liquid remains constant and that value is given as how much? 1.2 gram per ml. Correct. So I can substitute that for density, that is 1.2 gram per ml. Now I could cancel this one, this ml and ml can be cancelled. So this will become 24 or 2.4 gram. Correct. So right now I know mass of 35 drops of liquid, I know it is 2.4 gram. Correct. So we will write it like this. Okay. So mass of 35 drops of liquid is equal to 2.4 gram. Now what we can calculate from this? So we can calculate, we can write it like this actually, 35 drops of liquid liquid has a mass of 2.4 gram. Now for one drop of liquid, how we can get it? Divide by 35 on both sides. Correct? So I can say for one drop of liquid, for one drop of liquid, mass is equal to 2.4 divided by 35 gram. Now I know one drop of liquid has a mass of this much. But what they are asking you in the question, they are asking you the number of molecules in one drop. That is what they are asking. I know one drop of a liquid is having 2.4 gram, 2.4 by 35 gram is present. Okay. Now, but they have given one more clue. Molecular weight of the liquid is given as 70. So that we will note down here. We can say here molecular weight of the liquid, molecular weight of the liquid is equal to 70 gram. Okay, molecular weight expressed in grams, correct. Now tell me what is the relation between molecular weight of any substance and Avogadro number. You know that molecular weight of any liquid or any compound will contain how many molecules? Avogadro number of molecules, correct. So I can say that 70 gram of the liquid, 70 gram of the liquid contains how many molecules? Avogadro molecules of liquid. Avogadro molecules of liquid. Correct? Okay. Now 70 gram contains Avogadro molecules, but can you tell me one drop is having which mass? 22.4 divided by 35. So I need to know in 2.4 divided by 35 how many molecules are there, because 2.4 by 35 corresponds to how much drop? One drop. In question they are asking number of molecules in one drop. So let me find out for 1 gram. So 1 gram of liquid, 1 gram of liquid has how many molecules? Na by 70 molecules of liquid. Na by 70 molecules of liquid. Correct. Now, now tell me how to get it for 2.4 by 35. Multiply by that value. That is 2.4 divided by 35 grams. So this will become 2.4 by 35 gram of liquid has how many number of molecules? Na by 70 into 2.4 by 35 molecules. Correct? Molecules. Correct. Now, how I can simplify this actually? I can say this 2.4 can be cut with this one. So this can be written as Na by 35 into, if you cut with this will become 1.2 by 35. So I can say Na into 1.2 divided by 35 the whole square. This is the answer. So 2.4 gram of liquid corresponds to what actually? Tell me. This corresponds to one drop of liquid. One drop of liquid. Correct? So now read it. One drop of liquid has a mass of 2.4 by 35 gram and it has how many molecules? Na by 35 square into 1.2 molecules. So this is how we need to do it. So we will look for that option. Okay, that is Na by 35 square. So I hope, yeah. So we have the option here, Na by 35 square into 1 point. So option C will be the correct answer. So we have a beautiful question in front of you. Just read the question. The number of neutrons in a drop of water, and it is mentioned like 20 drops is equivalent to 1 ml at 4 degrees Celsius is. So this is the question. So they are asking you the number of neutrons in one single drop of water. Okay, and they told that 20 drop is equivalent to 1 ml. So we will try to see how to solve this question. Okay, So I will take a color. Mm, okay, I would like to take green color. Okay. Now, in the question they have mentioned like 20 drops, correct? 20 drops is equal to 1 ml, correct? Now tell me, one drop is equal to how much volume? Then how to get one drop? Divide by 20 on both sides. So this will become one drop is equal to 1 divided by 20 ml. So this is the volume of one drop, correct? Now we can find out the mass of one drop of water. So mass of one drop of water, one drop of water, H2O, okay, is equal to, we know mass is equal to volume into density. And always remember, density of water is always fixed. So density of water is how much? 1 gram per ml. So we know volume of one drop is how much? 1 by 20 ml multiplied by density of water, which is always fixed, 1 gram per ml. So we know that this ml and ml get cancels off, and you will get the mass as 1 by 20 gram. Correct? So right now I know the mass of one drop of water. Now let us calculate the number of moles. Okay. The number of moles present in one drop of water. Number of moles in one drop of water. One drop of water. Correct? So how to calculate the number of moles? We know weight in gram divided by, what you should do? Weight in gram divided by molecular mass. So we know what is the weight in gram of one drop. You know it is 1 by 20. The molecular mass of water is how much? 18. So this value will come around 1 divided by 360. So you got the number of moles. Now we will try to do calculate the number of molecules. So I know that 1 mole 1 mole of water has how many molecules? We have learned this Avogadro number. So that is Na molecules. Correct? Correct. Na molecules of water. Now, how much moles you have? 1 by 360. This 1 by 360 is present in how much drop of water? One drop of water. So we know that one drop of water has 1 by 360 moles. So we will convert this 1 into 1 by 360 by multiplying by 1 by 360 on both sides. So this will become 1 by 360 mole of water, okay, has how much? Here also multiply by 1 by 360. Na by 360 molecules. Correct? Na by 360 molecules of water. Correct. So right now we have 1 by 360 mole has how many molecules? Na by 360. And this 1 by 360 mole of water is equivalent to how much? This is equivalent to, we know that we have learned this as 1 drop of water. Correct. This is equal to 1 drop of water. Now, now we got the answer as Na by 360. So this is the answer, but the options are given in numbers. So how to do it? So we will say 6.022 into 10 power 23 divided by 360. So what this value will become? So if you do it, this value will be 1.67 into 10 power 21. So right now we know one drop of water is having how many molecules? Correct. So we know that one molecule of water, if you take one molecule of water means H2O. Okay. How many neutrons are there? The number of neutrons in the case of hydrogen is equal to 0. So for oxygen, we know the atomic number is 8. So to get the number of neutrons, mass number minus number of protons, that is 16 minus 8, it will have 8 neutrons. Correct? It will have 8 neutrons. That is one molecule Water has 8 neutrons. We have how many molecules? We have 1.67 into 10 power 21 water molecules are there, because that corresponds to one drop of water. So we will multiply this on both sides. So this will become 1.67 into 10 power 21 water molecules. Correct? So multiply by same number on the RHS. So this will become 8 into 1.67 into 10 power 21 neutrons. Correct. So what is this value equal to? So this value, if you do it, this will become 1.338 into 10 power 22 neutrons. Okay. 1.338 into 10 power 22 neutrons. So right now we have got the answer. So we will come back here. So which option corresponds to that? 1.338 into 10 power 22. So that is option B is the correct answer. So we can say option B is the correct answer. We have a new question in front of you. Okay. So the total number of ions present in 1 ml of 0.1 molar barium nitrate solution is. Okay. So they are asking you to calculate the total number of ions which is present in what? 1 ml of 0.1 molar barium nitrate solution. So since they have told about molarity, we will go with the standard definition of molarity. What is molarity? Tell me. Okay, molarity is equal to number of moles of the solute. So here the solute is what? Barium nitrate. Number of moles of the solute divided by volume of the solution. Okay, normally it should be in liters. If you are expressing it in ml, then the numerator should be multiplied by 1000. Okay. Now, how to calculate the number of moles of the solute from here? I can say the number of moles. Okay, instead of solute, we say barium nitrate. Number of moles of barium nitrate is equal to number of moles of barium nitrate is equal to molarity into molarity is 0.1, correct, multiplied by volume of the solution in ml. Volume of the solution in ml is equal to 1 ml divided by what will come into picture? 1000. Okay, so what will be this value? The number of moles will be equal to, I can say, 0.1 divided by 1000. Okay, I got the number of moles. So this can be written as 10 power minus 4. Now, I know that 1 mole of barium nitrate, BaNO3 twice, has how many molecules? Tell me. It has Avogadro number of molecules, that is 6.022 into 10 power 23 molecules will be there. Correct? Molecules. Now, tell me how many moles we have. We have 10 power minus 4 moles. So I can say you can multiply by 10 power minus 4 on both sides. So this will become 10 power minus 4 mole of barium nitrate, BaNO3 twice, has, you should multiply on the RHS also. So this will become what actually? So this will become, I can say, 10 power minus 4 into, instead of 6.022, I am writing it Na for convenience. This many molecules, correct? Now, we will speak about, now we know that this many number of moles are there, correct? So 10 power minus 4 mole has how many molecules? 10 power minus 4 into Na molecules, correct? 10 power minus 4 10 power minus 4 mole is what actually? This is equal to, tell me, 1 ml of 0.1 molar barium nitrate solution, correct? So 1 ml of 0.1 molar barium nitrate solution is equivalent to say 10 power minus 4 mole, and which has how many molecules? 10 power minus 4 into Na molecules. Now the question asked is total number of ions. So first I will calculate in one molecule how many ions are there. So I will speak about one molecule barium nitrate. Barium nitrate can give how many ions? We know that when it splits up, how many ions will be formed? I can say this will be splitting up in such a way that there will be barium 2 plus, correct? Barium 2 plus and 2 NO3 minus. This is how the barium nitrate split it up. So totally how many ions are there? 3 ions. So that means one molecule of barium nitrate can give rise to 3 ions. Now tell me how many molecules you are having. So you are having 10 power minus 4 into Na molecules. So I will multiply by 10 power minus 4 on LHS and RHS. So this will become 10 power minus 4 into Na molecule barium nitrate. Okay, do the same thing on the RHS also. That means 3 into 10 power minus 4 into Na ions. So I got the answer. So I will put it in a correct format. So I can say the actual answer is 3 into 10 power minus 4 into 6.022 into 10 power 23. So this is equal to 3 into 6 into 10 power 19 ions. So we will check out any options like that. So 3 into 6 into 10 power 19. 3 into 6 into 10 power 19. So which one corresponds to correct option? So you know that the correct option is option C. So we have a good question in front of you. I will just read the question. A gaseous hydrocarbon gives upon combustion 0.72 gram water and 3.08 gram of carbon dioxide. The empirical formula of the hydrocarbon is. So we have four options as well. So how to do this question? So they are telling it's a hydrocarbon. So it means combustion will give you what? Water and carbon dioxide. Correct. So we will just analyze. So we know that from our fundamentals, we know that 8 what is the, okay, we will write water. One product is water. So what is the molecular mass of water? I can say it is 18 gram. So if it is 18 gram, that is molar mass, correct? Molecular mass expressed in grams, or we can say molar mass. Now similarly, carbon dioxide, what is the molar mass for carbon dioxide? We know it is 44 gram, correct? So now if you see here, 18 gram of this water contains how much gram of hydrogen? I can say 2 gram of hydrogen. So I can write 18 gram of water, it, of water has 2 gram of hydrogen, correct? 2 gram of hydrogen. Now we need to find out in 0.72 gram of water how much gram of hydrogen is there. So we need to convert 18 gram to 0.72 gram. So first convert this to 1 gram. So divide by 18 on both sides. Okay. So this will become 1 gram of water. 1 gram of water has 2 by 18. Correct. On both sides we should divide. 2 by 18 gram hydrogen. Now we need to convert this to 0.72 gram water. For that we will multiply by 0.72 on both sides. So this will become 0.72 gram of water, correct, has 2 by 18 into 0.72 gram hydrogen. Now what is this value equal to? So if you divide, this value will be equal to 0.08 gram hydrogen. Now I have found out in 0.72 gram of water what is the amount of hydrogen. Why I am doing this? So if I get the mass of the hydrogen in that, corresponding to that I can find out the number of moles, correct? So if similarly if I find out the number of moles of carbon, that ratio will give me the simplest formula between carbon and hydrogen. That will be my empirical formula. Okay, so that is the reason why I am doing this. Now similarly we will do it with the carbon dioxide. So we know that we will write here 44 gram, okay, of CO2 has how much amount of carbon present? We know 12 gram of carbon is present. So let's find out for 1 gram. For that we will divide by 44 on both sides. So this will become 1 gram of CO2 has 12 divided by 44 gram of carbon, correct? So we need to convert this to how much gram. In the question they have given, if you see here, I can say in the question they have given value of carbon dioxide as 3.08 gram of carbon dioxide. So we will multiply with 3.08 on both sides. So multiplying with 3.08 on both sides, so this will become 3.08 gram of carbon dioxide, which has a mass of 12 by 44 into 3.08 gram, correct? 3.08 gram carbon. And if you divide, this value will come around 0.84 0.84 gram carbon. Now I know the amount of carbon and amount of hydrogen that is present in the given gram. 0.72 gram water has 0.08 gram hydrogen and 3.08 gram of carbon dioxide has 0.84 gram of carbon. Now we will find out the corresponding moles ratio. So I can say the number of moles of hydrogen, number of moles of hydrogen is equal to how, what? Weight in gram. Weight in gram is how much we have calculated, that 0.08. So we will say 0.08 divided by the mass of hydrogen. So we know the mass of hydrogen being 1. So we will get this as 0.08. Correct? So similarly, the number of moles of carbon, number of moles of carbon is equal to weight in gram. We have calculated that 0.84 divided by atomic mass of carbon, that is 12. So if you divide this, you will get it as 0.07, correct? 0.07. Okay. Now we will try to see the simplest ratio of this one. Okay. So we can say this is equal to carbon is to hydrogen is equal to 0.07 is to 0.08. So that means we cannot further make this to simplest value. So the value should be, since it is a ratio, we can say this is can be round as 7 is to 8. Correct? So we say the simplest formula possible is C7H8. Correct? So I hope you understood. So we will see whether this option is there. C7H8. Yes, it is present as option D. So I can mark that as my answer for this question. So I will just read the question. In Haber process, 30 liters of dihydrogen and 30 liters of dinitrogen were taken for reaction, which yielded only 50% of the expected product. What will be the composition of the gaseous mixture under the above set conditions in the end? Okay, very good question. So let's write how this reaction looks like. Then we will go into details of the question. Okay, so which pen do you like? So let me take violet. So what is the reaction here? So I can say the fundamental reaction here is nitrogen, okay, which is in gaseous format, reacting with hydrogen, correct, which is also in gaseous format, forming ammonia, NH3, which is also in gaseous format. And if I balance this, you know that I can keep 2 here. So 3 into 2, 6 hydrogen. So I will keep here 3. Okay, and if you see here 3 into 2 6, and if you see here we can say 3 hydrogens are here and 2 ammonias are there and nitrogen 2. So now it looks like balanced. So if you write the stoichiometric ratio, I can say stoichiometric ratio of this equation, stoichiometric ratio of this equation is 1 is to 3 is to 2. Correct? Now, here we can apply Gay-Lussac's law of combining volumes because all the reactants and products are in gaseous state. So I can write apply Gay-Lussac's law. Apply Gay-Lussac's law. Correct? Gay-Lussac's law. Now, what the law states that one volume based on the stoichiometry, I can instead of writing in the terms of moles, I can write it in the terms of volume. So I can say one volume nitrogen combines with 3 volume of hydrogen to form 2 volume of ammonia. This is what. Now here I can do one thing. I can assign volume to anything. So let's assume, okay, let's assume one volume, one volume is one volume is 10 liters, or we say 1 liter, that is sufficient. Then we will multiply with 10. That is more understanding way. Okay, so let's assume one volume to be 1 liter. Okay, so how I can write this now? 1 liter 1 liter nitrogen needs 3 liter hydrogen to form 2 liter ammonia. Correct? Now let's multiply by 10 on complete thing. So I can say 10 liter nitrogen needs 30 liter hydrogen to form 20 liter ammonia. Now you can ask, sir, why you multiplied by 10? The reason for that is in the question given, they have given 30 liter of nitrogen and 30 liter of hydrogen. So we will assume here, we will check here what is given to you for your preparation. Given to you is 10, okay, 30 liter nitrogen and 30 liter hydrogen. So this is what given to you. Now you itself tell me based on Gay-Lussac's law, I know that 10 liter nitrogen needs 30 liter hydrogen to form 20 liter ammonia. Correct. So tell me which will be the limiting reagent here. Surely nitrogen will be the limiting reagent. Nitrogen or hydrogen. So here if you see 30 liter hydrogen is completely used here. Correct. So if I say as per this reaction 30 liter hydrogen is used, and when you are using 30 liter hydrogen, how much amount of nitrogen is required? Just 10 liter is required. Correct. So the remaining liter of nitrogen is how much will be remaining? 30 minus 10. So I can say here 30 liter hydrogen is used. So hydrogen used is equal to 30 liter completely used, and nitrogen used will be equal to how much? Nitrogen used will be for 30 liter hydrogen only 10 liter is required. Correct. So if nitrogen, how much nitrogen is left behind? Nitrogen left behind is how much? I can say initial given is 30, used is 10 liter. So 30 minus 10, that is 20 liter is left behind. Correct. So tell me who is the limiting reagent here? So I have told earlier in a wrong way. The limiting reagent here is hydrogen because there is no more hydrogen left behind. The given is 30 liter, and as per stoichiometry, we understood that 30 liter hydrogen is required. Correct. So when 30 liter of hydrogen is used up, only 10 liter nitrogen is required. So remaining will be we know that nitrogen left behind will be 20 liters. So nitrogen is available in excess. So the limiting reagent is hydrogen. Limiting reagent is hydrogen. Correct. Now I have told 20 liter. Now what about ammonia's case? Ammonia formed will be under this condition. What will be the ammonia formed here? NH3 formed here is equal to 20 liters. Correct. Now if you see here, I can say in options they are talking only with respect to what? So if you see here with respect to ammonia, nitrogen and hydrogen. Correct. But they are telling one important point here. They told even though they have taken 30 liter of dihydrogen and 30 liter of dinitrogen, only 50 percentage, correct, which yielded the reaction yielded only 50 percentage of the expected product. Now we know what is the expected product. So I will write expected. Expected product is what? Tell me. So my expected products are, correct. So if you see the expected products are 20 liter ammonia is expected, correct. 20 liter ammonia is expected, correct. So this is the my expected product, 20 liter ammonia. But actual output obtained, product actual product obtained is how much? 50 percentage. 50 percentage of expected product. 50 percentage of expected product, correct. So that means 50 by 100 into 20 liters. 20 liters, that is how much? It will come around 10 liter ammonia. Understood? Now they are asking you a question. So to obtain 10 liter ammonia, how much amount of nitrogen and dihydrogen is used? That is what they are asking. Last sentence, if you see, you can see here the question asked here is what will be the composition of the gaseous mixture? They are asking what will be the composition of the gaseous mixture under the above said condition. Above said condition means 50% of the output product formed. So we will see what is the composition of gaseous mixture. So let's find, to get 10 liter of ammonia, that means how much amount of nitrogen and dihydrogen is needed. So we know that 20 liter needs, we will write like that. So 20 liter ammonia production, ammonia production needs 30 liter dihydrogen and 10 liter dinitrogen. Now tell me, 10 liter ammonia means half of that. Production needs 10 liter ammonia production needs how much? Tell me. 15 liter of hydrogen and 5 liter of nitrogen. But is my answer 15 and 5? They are asking you the after the reaction composition of the gaseous mixture. Composition of gaseous mixture after the reaction, correct. What will be the composition of the gaseous mixture? So you know that 10 liter ammonia is formed, correct. So 10 liter ammonia will be there, that is one thing. And 15 liter hydrogen is used in the reaction. This is a reactant, correct. So this 15 liter is used. So what is left behind? Initially 30 liter were there, 15 liter is used. So I can say 30 minus 15 liter of hydrogen, that is I can say 15 liter hydrogen is left behind as composition, that is present in the reaction medium. Now how much amount of nitrogen is left behind? Initially you know that how much is taken? We have taken 30 liter of dinitrogen, and how much is used? 5 liter. So 5 liter is used. So I can say 30 minus 5 liter is left behind, that is 25 liter dinitrogen is left behind. So that means 10 liter ammonia, correct, in the gaseous mixture. 10 liter ammonia, 15 liter of dihydrogen and 25 liter of dinitrogen is present. Okay, so we will see any options like that. Okay, so if you see, as per this, 10 liter of ammonia and 25 liter of nitrogen and 15 liters of ammonia, 15 liters of hydrogen. So which is the option correct to that? So option A is the correct answer. So I hope you understood this question. Very important question. To understand this, the pivotal point of this question is the last question, that is, what will be the combustion of the gaseous mixture? They're asking you, after the reaction there will be something that is present as gases. So what is its combustion? That is what they are asking. They are not asking you how much amount of nitrogen and hydrogen is required to form 10 liter of ammonia. That is not they are asking. They are asking you what will be the combustion of the gaseous mixture under the above set condition. Above set condition is 50% of the expected product. Okay, so I hope you understood this question. This is very important question for NEET. Please learn this. If you have any doubts, get back to us. So just read the question. The specific volume of a cylindrical virus particle is given as 6.02 into 10 power minus 2 cc per gram, whose radius and length are 7 angstrom and 10 angstrom respectively. If Avogadro number is equal to 6.02 into 10 power 23, find the molecular weight of the virus. So this is the question here. So let me first say a new term is used here. Okay. So I can say the new term used here is specific volume. Okay. So what do you mean by specific volume? What is this? This is what first I am going to define. I can say specific volume is equal to volume of 1 gram, or volume occupied by 1 gram of the substance. Volume occupied by 1 gram of the substance. Okay. Volume occupied by the 1 gram of the substance is called specific volume. Now here they are talking about cylindrical virus particle. So we say it is cylindrical in nature. So cylindrical virus particle, correct? Cylindrical virus particle. Now, since it is cylindrical and they have mentioned its specific volume is how much? 6.02 into 10 power minus 2 cc per gram. So let me say one thing about cc actually. Cc means cubic centimeter. So 1 cc is equal to 1 ml. This you should know. This is a fundamental relationship. Centimeter cubed. Cc means centimeter cubed. So they are indirectly what they are telling, specific volume is 6.02 minus into 10 power minus 2 cc per gram. That means 1 gram of the virus has a volume of 6.02 into 10 power minus 2 ml. Understood? So let me write that 1 gram of the virus, 1 gram of the virus occupies a volume of 6.02 into 10 power minus 2 cc. Cc means 1 ml. So I will write ml. Correct. So this is the initial understanding of this question. And they have told the virus is cylindrical in nature. So let us calculate the volume of the virus. I will write volume of the cylindrical virus. Correct. So that it is easy for you to remember the formula. Volume of the cylindrical virus. So we know the formula of cylinder. What is the formula of the cylinder? You might have learned in max. It is pi r square h or pi r square l. Anything you can say. Height. So pi I know it is 22 by 7. Okay. Radius they have mentioned it 7 angstrom. So we are talking everything in centimeter cube. So let's convert into centimeter. So I can say 7 angstrom is equal to 7 into 10 power minus 10 meter, which is equal to 7 into 10 power minus 8 centimeter. So pi r square means this will come in enclosed bracket into how much length, what they have given? They have given 10 angstrom. So that means 10 into 10 into 10 power minus 8 centimeter. So if you multiply these values, you will get something like 154 into 10 power minus 23 cc or ml. This is the volume. Either you can say it in cc or in ml. Now I know the volume of the cylindrical virus. Okay, now let us calculate. Now we know two things we know actually. So one thing is 1 gram of the virus has what volume? Now we will find out. We say it like this: 1 gram virus has a volume of 6.02 into 10 power minus 2 ml. Correct? Now let us calculate what is the mass of 154 into 10 power minus 23 ml of virus. So how can you calculate that? We need to convert this value to 154 into 10 power minus 23 ml. So for that we will just first convert this to 1 ml. To make this 1 ml, what we should do, divide by the same number. So 6.02 into 10 power minus 2. I will divide by this number. So this will become 1 ml and this will become 1 divided by 6.02 into 10 power minus 2 gram virus. So now we know that 1 ml, if you take as the volume, 1 ml if the volume of virus is taken or volume of virus is taken, it will have a mass of 1 by 6.02 into 10 power minus 2 gram. Correct. Now we need to find out the mass corresponds to what? 154 into 10 power minus 23, because that is the volume of the cylindrical virus. To get that, I will multiply by this number 154 into 10 power minus 23. So this will become 154 into 10 power minus 23 ml. So multiply by the same number here. So this will become 154 into 10 power minus 23 divided by 6.02 into 10 power minus 2 gram virus. Now I know the mass corresponds to this volume, correct? So if I divide this, I will get a mass corresponds to 154 ml, correct? Now, now I need to find out what is the molecular weight of the virus, correct? So that is what is my question here is. Now if you see here, find the molecular weight of the virus. I know molecular weight of the virus means what actually? I will write here molecular weight of the virus is equal to what actually? It is the weight of how many particles we have learned in our fundamentals. We know that Avogadro number, correct? Avogadro number of particles is present in molecular weight. That means molecular weight of the virus is what actually? Weight of Avogadro number of, correct? Weight of Avogadro number of virus particles, correct? That is will be the molecular weight of the virus, correct? Now we need to find out weight of Avogadro number of virus particles. So how we can do that? So we know that one virus, one virus, one virus particle, one virus particle has a volume of, one virus particle has a volume of 154 into 10 power minus 23 ml, correct? One virus particle has a volume of 154 into 10 power minus 23 ml, and it has a mass of how much? It has a mass of 154 into 10 power minus 23 divided by 6.02 into 10 power minus 2 gram. This is the mass, okay, and this is the volume. So we know volume of one virus particle and mass of one virus particle. But I know the molecular weight of the virus is the mass of Avogadro number of particles. Correct. So one virus particle is weighing this much. 154 into 10 power 23 by 6.02 into 10 power minus 2 gram. So Avogadro number of particles means you need to multiply by Avogadro number. So I can say mass of one virus particle particle multiplied by Avogadro number will give me the answer. So what is the mass of one virus particle? I can write it like 154 into 10 power minus 23 divided by 6.02 into 10 power minus 2 multiplied by 6.02 into 10 power 23. Okay, so if you do this calculation, I can say you will get 15400 gram per mole. This is what you are getting. But if you see here, the options they are given in kilogram. So we need to convert this into kilogram. So I will get the answer divide by 1000. So this will become 15.4 kilogram per mole. So I hope you understood the question. Very simple. We have calculated the volume of one virus particle. Then we calculated the mass corresponding to that one virus particle. We know that molecular weight is the weight of Avogadro number of virus particles. So we multiplied mass of one virus particle with the Avogadro number to get the molecular mass of the virus. So tell me which is the answer corresponding to this question. I can say 15.4 kilogram per mole. So option B looks the perfect answer. So I hope you understood the question. So if you have any doubt, get back to us. And for more questions, please subscribe our channel. And if you need detailed theory and support in your studies, you can contact Brainiacs Classes for complete services. Thank you.